So this problem says to find all the roots using your calculator. So it is pretty easy to get all of your real roots from a graph. If you just type in that whole polynomial as y1, you can type it in right here. And then once it's drawn out, once you get it all typed in, draw it, you can see roots by looking at the graph. You can get more roots by going on a Casio, pushing gsolve root. And kind of weird because we can't see the line there, but sometimes graphs just do that. You cannot see the line passing through -5, but apparently there's a root there. There's another one at 0, so -5, 0. There's another at 1. Now, since it bounces at 1, that means it has a multiplicity of 2. And an even multiplicity because it bounces instead of passing through. So we have, for sure, roots at -5, 0, and 1 with a multiplicity of 2. I'll push right one more time, see if there's another one. That's the last one it finds. We have roots at -5, 0, and 1 with a multiplicity of 2. So by looking at the graph, we were able to find our real roots. We found 4 of them. We found 4 of the roots. There are 6 total. So there's 2 more that we couldn't find, which means there's probably 2 that are imaginary, which the graph can't help us with. So instead, we can find those other 2. Now, if your calculator doesn't have this function, there's no option but to do synthetic division and divide off -5, 0, 1, and then 1 again, and then you're going to be left with an x squared something. You could do that, but it's a lot of work by hand. If your calculator has the function, go to equation solver 8. And this is a polynomial, so we will choose polynomial. It was a degree of 6, so select 6. And then you need to type in all of your coefficients. So the first one is the coefficient in front of x squared, and it just counts down. So type in all of those coefficients. So once you get all of your coefficients typed in, as 1, -1, -8, 80, -137, 65, and 0, because there's no constant term. Before you do anything else, make sure that your calculator is set for imaginary solutions. So you need to go Shift Setup and make sure that complex mode is set to A plus BI. If it's set for real, you're not going to see anything except for what the graph just shows. It'll show us the -5, 0, 1, and 1, and it won't show us the imaginary. So make sure complex mode is set for A plus BI. And then you can solve. -1 times 2, it tells us the multiplicity right there, which we knew by looking at the graph. 0, -5, and then it also gives us our 2 imaginary answers because the calculator is set for that. 2 plus 3i and 2 minus 3i. Notice that, like we talked about before, they always appear in conjugate pairs. So 2 plus 3i and 2 minus 3i, they have to be the same, but just conjugates. Let's write down those last 2. And there's all 6 roots. from the calculator.